Hello and welcome. This is RC2 with Dr. Usama Abed. My name is M.Fares. I am in group number 1. Our project is about multi-story office building. Starting by the table of the content, first of all we have the introduction. Then we have the objectives, the procedure, slab thickness, load distribution. Also we have one-way and two-way slabs. We have sway and non-sway columns. We have design beams and foundation designs. And then we will have a brief summary for what we all will discuss. We will explain each one of them. Let's start with the introduction. First of all, we know in a period of time they used in their building mud and concrete. But after a while, they discovered that concrete doesn't handle the tension. So they added by steel bars, which can handle tension, force. And by tension and compression, concrete and steel can handle the job and keep your building safe. So we have types of slabs. We have one-way or two-way. The one-way we can find it by long over short. If it is less than 2, it will be one-way, or greater than 2, it will be two-way. Going by the types of the two-way slabs, we have the solid flat plate and flat plate, solid slab, flat plate, and flat slab. Then we will have a waffle slab, which is, we didn't study it, but we studied about these first three, or the three of them. Our project is to design a fully structure of 5-story, multi-story building. It's about an office building, and we will start it from the foundation to the final level, which is the final floor, and we will try our best. We tried our best that we keep it safe. The objectives is that we have design slabs. The design slabs, like as we said, one-way and two-way. In two-way, we have the solid slabs and flat plate and flat slab. Each one of them have a certain procedure. Then going by design columns, we have the slender and short. We can recognize them after doing a procedure. Then we have the design beams as we took in RC1, which is T, L, and R. Then we have the foundation. Well, the suitable foundation for us is the raft foundation because it can handle all the loads coming from the columns. And this is our structure designed from AutoCAD. Going by the procedure, we have a certain procedure to design a slab. We have to find the minimum thickness and then calculate the ultimate load and so on. We have the most important thing is to find Rn and rho, and then we can compare between rho and rho minimum. Then we can find the area of steel, which is rho multiplied by B and D. Then we have the procedure of design of beams, which is we have to evaluate the ultimate load, and we have to find it if it is T or L or R. Then we have the procedure for column, which is to evaluate the dimension of the columns, and then etc. to have the design the column and get the cross section. Now we have this table, which is an ACI code. We will use it to find our slab thickness. So first of all, we have the Ln, which is L1 minus 0.3. We found that it is 7.7. When we go over here, we choose 420, and it is with edge beam, so we use Ln over 33 as ACI code. And we did the procedure, and we had to take 900 millimeter. Then for the slab, it was 4,150 millimeter. Going by the next slide, here we have a cross section for the example before. Then we used this graph, the interaction diagram, just to find the I, where we have alpha over h, and we have 1.2, so here we had approximately 1.4 or 1.5 or something. So going by the slab thickness, we have also the procedure after getting the 1.59, okay, we choose it 1.59. Then we have the procedure to get LB and for the beam and for the steel, and then we get alpha, which is beam over steel. Then we had it greater than 0.8, which is, so we can consider it as edge beam. So going through, we have the same example here. Then we use the table again. Going by the solid slabs, we have the this rule to find the flat plate in punching shear. So we have this rule, which is VC, and then we have a certain procedure to find it. Now going by the procedure, we have to find H. We found it until we got it 350 millimeter. And here it is safe software. We have a screenshot for the punching shear, which is H 350 millimeter, and here it's 0.6. Also, we have the load distribution. We found it. This is by the two-way. Then we found it by AutoCAD. This is the tributary area for a solid slab. Going on load on beams, we used AutoCAD to draw these drawings. We have the beam. We have to find the WSU, which is 11.2, and then we have to find all the loads as we used in reinforced concrete one with Dr. Osama Abed. Now I will end up here. Thank you for your listening. Thank you.